Okay, in this video we're going to derive an expression for the inverse hyperbolic cotangent of u. And as you've been doing in the other videos, we do that by recalling the logarithmic form of this inverse function, and then we take the derivative of the logarithmic expression. So here we say, let this be equal to y. Remember then that y has to equal 1/2 the natural log of u plus 1 divided by u minus 1. In other words, for the inverse hyperbolic cotangent function, this is another way of expressing that. And we have derived all of these expressions here, logarithmic expressions for inverse hyperbolic functions. We derived a lot of those in previous videos, so if you haven't seen them yet, you might want to look them over. And now what we're going to do is say, okay, suppose we want to find d dx of inverse hyperbolic cotangent of u. Well, since this is what y is, that would be the same thing as finding dy dx, and y is equal to this logarithmic expression. So let's get busy and find dy dx. That will equal 1/2 times 1 over this expression, or that would be the reciprocal of this. Then we have to multiply that by the derivative of this expression. So let's see, we're going to have this here, u minus 1, times the derivative of this, which is just going to be du dx. We have u minus 1 times the derivative of this, and that's just going to be du dx. And then we have minus this times the derivative of this, and that's just going to be du dx, the derivative of this part. And this whole thing now is going to be divided by the square. So let's see. I guess we might as well do the cancellations now. So this will equal 1 over 2 times u plus 1. And then we'll factor out this du dx. This is over u minus 1. We have u minus 1 times du dx. And then from here we're going to have minus u minus 1. And this is times du dx. We factor that out of there. Put this all the way across. So let's see. It looks like the u's are going to cancel. And that's going to give us minus 2 on top. So we have from here 1 over 2 times u plus 1. And then from up here we have minus 2 divided by u minus 1 times du dx. That's just minus 1. So this equals minus 1 over this times this. 2's cancel. We have a minus sign here from this minus 2. And we have 1 over this times this. So that is u squared minus 1 times du dx. Or multiplying through by minus 1, this would equal 1 over 1 minus u squared du dx. And that is what dy dx is. Way back up here. But dy dx, and back to where we had this set up, y is this, so dy dx is the same thing as this, the derivative of this with respect to x. So finally we can come down here and say then that d dx, the inverse hyperbolic cotangent of u, is equal to this. And again, not too difficult to do. We included a lot of these, deriving a lot of these derivatives, mainly because it's a good exercise in remembering how to carry on with how to perform logarithmic differentiation. And really, and I think almost every video, this step here is the only calculus step, and all the rest of it is just kind of shifting through the algebra. But anyway, this is what we get for the inverse hyperbolic cotangent function. But that kind of wraps it up for this video. So come back, join us for some more videos, and we'll see if we can solve some more problems.